Assalamualaikum and hello everyone. Welcome to the video where we will be discussing past year question for the year of 2020 and 2021. In this video, we will discuss the questions regarding chapter 1 itself, which is question number 1. So for the year of 2020 and 2021 here, for question number 1, we have A, B, C, D. So in total, we have 4 questions regarding chapter 1 itself. So we're going to discuss one by one for the questions. So let's have a look. Number 1, write the isotopic notation for silicon atom. So what is actually isotopic notation? Okay, isotopic notation is actually how you write down your atom with the proton number and the nucleon number itself lah. Okay, so how do we write it down? So here we have your X. X is your symbol. Okay, for example, we have our sodium, but then we're not going to write down sodium, the full name. We're just going to write down the symbol. Okay, sodium, the symbol is Na. If we have carbon, for example, okay, carbon is the full name, but the symbol itself is C. Oxygen. We have our oxygen, the full name is oxygen, but then the symbol would be capital O. Okay, so this is what it meant by symbol. Okay, A is the nucleon number or atomic mass. Okay, so nucleon number ni is actually your proton plus neutron lah. Okay, but then based on your list of constant, it's actually your atomic mass. Atomic mass and the nucleon number is the same. Okay, here and your Z is your proton number. Okay, so the question asks to write down the isotopic notation for silicon atom. So we have our silicon here. So we're going to start with Si. This is our silicon. And then, okay, so what is the proton number? Okay, you don't have to memorize it. We're going to look based upon our list of constant. Okay, so here is the list of constant. Okay, we're going to find for silicon. So silicon is actually at the bottom here. So we have our silicon here. The second column is actually our symbol. This one is actually our proton number. Proton number is your Z lah. Okay, this one is actually your atomic mass or your nucleon number itself, which is your A. Okay, so Z is 14, A is 28.1. Okay, so we know that our Z just now is actually 14. Okay, and then my proton number, my nucleon number or atomic mass is 28.1. So I'm just going to write down here 28.1. Okay, so here is actually how to write down the isotopic notation for question number 1. Question number 2, Roman. Calculate the number of Si atom in 50 gram of Na2SiO3. Okay, so how do we find out the number of atom? Okay, so here it mentioned it want only for the silicon atoms in our Na2SiO3. Okay, so how do we find out the number of atoms? Okay, it is based on our Avogadro constant. One mole of our molecule itself is actually equal to 6.02 exponent 23 atoms. Okay, so how do we find out the number of mole? Okay, so for the number of mole, we found out from number of mole equal to mass divided by molar mass. How do we find out the mass? The mass we have from the question lah usually. The molar mass is actually from the list of constant. Okay, based on the information given, we have 50 gram of our sodium metasilicate. Okay, so first we're going to find out not the mole of Si, we're going to find out the total mole or the number of mole of our molecule itself lah. Okay, so I'm just going to write down the number of mole here. Number of mole of sodium Na2SiO3. So the mass is actually 50 gram. Okay, how do we find out the molar mass? Okay, so the molar mass is actually from the list of constant. So let's look at it. So we have Na2SiO3. So we are interested in sodium. Okay, so the molar mass for the sodium, based on the list of constant, is actually the most right hand side lah. Okay. Okay, so sodium is 23.0. Silicon is actually this one, 28.1. Oxygen is 16. Okay, but then when you calculating the value, remember the sodium we have 2. So for the sodium, we must multiply by 2. Oxygen, we must multiply by 3. So let us substitute to the value for the molar mass. Remember here, sodium times 2, oxygen times 3. Okay, we're going to find out the number of mole. Okay, then when we calculate the number of mole is actually 0.4095 mole. Okay, so this is actually for the mole of our sodium metasilicate itself. Okay, again, we don't want the value for the atom for the Na2SiO3. We are only interested in our silicon atom only. Okay, so from here we can see that in 1 mole of our sodium silicate, we have 1 mole of our silicon. Okay, so from there we can find out the number of mole of Si lah. So I'm just going to write down this stoichiometry coefficient. So 1 mole of sodium metasilicate equal to 1 mole of silicon. Okay, if the question asks to find out the atom of Na here, kalau Na because we have 2 kan. So sini jadi equivalent to 2 mole of Na and equivalent to 3 mole of oxygen. But then this question only one for the silicon itself. Okay, so from here, since we know Na to SiO3 is 0.4095. So we know that the mole of silicon is also 0.4095 of mole. Okay, so this is only for the number of mole. Okay, so back to the question. They ask you to calculate the number of atoms. And then we know that 1 mole equivalent to 6.02 exponent 23 atoms. Okay, so we're going to find out the mole, or we're going to find out the atoms. Okay, so Si atoms is actually number of mole of Si times dengan Avogadro constants. If you don't remember the value for the Avogadro's constant or the Avogadro's number, actually you can refer to the list of constant. Here the Avogadro's number itself, here the symbol Na, and this is the value. Okay, next we're going to substitute the value here 0.4095 times with our Avogadro constant. So we will get the value to be, the value of Si atom is 2.47 exponent 23 atoms. Okay, since the question asks for the number of atoms, so the value with the unit will be atoms itself lah. Okay, so unless it is the final answer, then you can take 2 decimal places. If we haven't reached the final answer yet, take it to 4 decimal places. Okay, so that is for the question number 1A. Let's continue with question 1B. The following reaction take place in an acidic condition. We have MnO4 minus plus Fe2 plus will produce Mn2 plus plus Fe3 plus. So we're going to balance this equation out. Okay, so this equation is actually a redox equation where we're going to balance the ion electron method. Okay, so how to balance it out? Okay, so you have to balance it out in terms of ouch. Okay, so what does it mean by oucher tu? So what is oucher? A is actually stands for atom. We're going to balance the equation in terms of atom. Okay, next, once we have balanced it out in terms of atom, we're going to balance in terms of oxygen. Okay, so how to balance the equation? So where the side where we have less of our oxygen, we're going to add H2O. Okay, once we have balanced oxygen, we're going to balance the hydrogen. Okay, so where the side with less number of hydrogen, we're going to add H plus. Okay, so actually we're going to, once we have balanced all the atoms, this one ini besides oxygen and hydrogen lah. Okay, and then we're going to balance oxygen and balance hydrogen. Okay, next is actually we're going to calculate the charge on both sides, on the reactant and on the product side. Okay, once we have calculated the charge, usually it is not balanced. Once you have determined which one is more positive value, you're going to add electron to it, where the equation will balance on the reactant and the product side. Okay, so for this one, okay, let us do it together. Okay, so first thing first, we're going to divide this equation. Okay, so as you can see here, what we have is actually Fe2 plus and we have our Fe3 plus. Okay, and then we have our MnO4 minus, we become Mn2 plus. So first, what I'm going to write down the equation. I'm going to write the separate equation for this species itself. Okay, so this is the equation. Okay, next, what I'm going to do, I'm going to balance it out in terms of oucher lah. Okay, so in terms of oucher, so first I'm going to settle this equation first. For the ferrum 2 plus will become ferrum 3 plus. Okay, in terms of atom, it's already balanced because here ferrum we have 1. Here ferrum we only have 1. The difference is actually the charge lah. But in terms of atom, it is balanced. So there's no oxygen or the hydrogen on this side. So we don't have to add H2O or H plus. Okay, next is in terms of charge. So for the reactant side, we have 2 plus. And our product side, we have 3 plus. So we're going to add electron to the more positive side, which is our Fe3 plus lah. So how many electron we're going to add? We're going to add the electron so that it will be balanced our left hand side and our right hand side. So how many electron I'm going to add? I'm only going to add only 1. Okay, plus 1 electron. Okay, because right now positive 3 and negative 1 will become positive 2. This one is positive 2. So this equation is balanced already. Okay. Next is actually in terms of our MnO4 become Mn2 plus. Okay, again, in terms of atom, it's already balanced, manganese and manganese. Okay, next is oxygen. Oxygen on the left hand side is 4, but my right hand side, I don't have any oxygen. So what I'm going to add? I'm going to add H2O here. So I'm going to add H2O. Okay, but then for the H2O, this oxygen is 4. So I'm going to add, because right now we only have 1 oxygen, so I'm going to add 4 H2O. Okay, so oxygen is balanced. Left hand side 4, right hand side is 4. Next, we're going to balance in terms of hydrogen. Okay, hydrogen now is actually 8. Because we have 2 of our hydrogen here. But then we have number 4 at the front. So how many hydrogen we're going to add? We're going to add 8. Okay, add 8H plus. Okay, because we're not going to add H2. We're going to add H plus lah. So it become 8H plus. Okay, so hydrogen is balanced. So right now, all the atoms is balanced. Now calculate the charge. So I'm just going to write down here. We have positive 8, negative 1. So total we have positive 7. Here we have positive 2, 0. So here is positive 2. Okay, so charge is already calculated. Next is we're going to add electron to the more positive side. Okay, so positive side is positive 7 lah. Okay, so why we're going to add electron? Because we're going to make sure the value will be the same. Okay, since the electron is negative value, so it assume as if we minus the value lah. Okay, so how do we change from positive 7 to positive 2? Okay, so we're going to minus 5. So again, since electron is negative 1, so we're going to add 5 electron. Okay, so when we add 5 electron here, so for example, I'm just going to delete this one. Okay, so here we have negative 5. So negative 5 plus positive 8 is actually 3. 3 minus 1, here is actually positive 2 as well. Okay, so it's already balanced. Okay, so when you're adding electron, you're not adding electron to cancel out the charge. We're going to add electron so that your left hand side and right hand side has the same charge. The same goes as the above one, the ferrum. Here is positive 2. Here, positive 3 minus 1. Positive 2. Okay, so actually what we're going to do is we're going to balance the left and the right hand side lah. Okay, so once we already have balance in terms of our chair, next we're going to combine this equation again. We're going to combine this equation again. Okay, so when we're combining the equation, what we want to do is actually we're going to cancel out the electron. Okay, so when you write down the equation, actually besides the outer, these two equation, the electron must be on the opposite side lah, so that you can cancel it out. Okay, so how to cancel it out or how to simplify it? Since the electron here is 1, electron here is 5. So this one, all of this we have to multiply by 5. Okay, so I'm just going to write down the equation again. Remember, here we have to multiply by 5. So here will become 5Fe2 plus, 5Fe3 plus, so 5 electron. Okay, and then we're going to cancel out the electron itself. Okay, so electron, electron. Okay, so once the equation is already cancelled out, so right now, okay, so check. For the species, is there any similar species that we can cancel out? Fe is by itself, Fe3 plus pun, none. The same goes here. Tak ada, there's none of the species that we can cancel out except electron lah. Okay, so again, what we're going to do is we're going to write down the equation again, where all the right hand side ni kita akan gabungkan in one place lah. Okay, equal to the product will be on the product side, which is on your right hand side. Okay, so this will be the equation. Okay, so as you can find out here, again, all the reactant must be on the reactant side, product on the product side. Okay, so when you mention in acidic condition, at the end of the equation, you have your H plus lah. Okay, for example, if the question was in basic condition, actually what you're going to do, you're going to add OH minus on both sides lah. Okay, make sure how many OH is based upon how many hydrogen OH plus you have. But since the question asks for acidic, this will be the answer for it. Okay, so when you calculate again, even the charge itself kan, the charge pun balance here, positive 10. Okay. So here is positive 10, positive 8, negative 1. So here is positive 17. Here 2, 0, so 15, 2 plus ni. Okay, on both sides, actually, not only the charge is balanced, on both sides positive 17. Actually, when you count the number of atom, ferrum, hydrogen, magnesium, and oxygen is already balanced. Okay, so that is the solution for question 1b. Let's have a look for question 1c. So, compound X has a molar mass of 294.20 gram. The analysis of X shows that it contains 26.58 gram of potassium, 35.35 gram of chromium, and 38.07 gram of oxygen. Determine the molecular formula and name X. Okay, so how do we determine the molecular formula? So to determine the molecular formula is equal to empirical formula, which is to the power of n or subscript n, where the n, how to determine the n, and we can calculate through mass divided by molar mass. Okay, so mass of the compound is already given for 294.20 gram, but how to determine the molar mass? Okay, so determine the molar mass, we have to know the empirical formula itself lah. Okay, so we know that potassium K, chromium Cr, oxygen O. Okay, so how many chromium, how many potassium, chromium, and oxygen present in the molecule itself? So that's why we have to determine the empirical formula, where we have to construct a table of molar. Okay, so how to construct the table itself? So again, this is actually how you construct the table. Ma stands for mass, and the unit is gram. Mol stands for the number of mole, the unit is mole itself. Ra is ratio. Okay, again it is ma, mo, ra. Okay, once we have find the ratio, then we know what is the empirical formula for the compound itself. Okay, so for the element, okay, we know that we have potassium, chromium, and oxygen. Okay, so we're just gonna add potassium, chromium, oxygen, and then the mass is already given. It's 26.58 for potassium, chromium is 35.35, oxygen is 38.07. Okay, this is all based on the information from the question. Okay, so how do we find out the number of mole? Remember, mole is equal to mass divided by molar mass. Okay, how do we find out the molar mass? It's actually based on the list of constant. Okay, so let's check together. Again, we want K, Cr, and oxygen. Okay, so based on the list of constant, you have to look on your most right hand side. Okay, so K is 39.1, chromium is 52, and oxygen is 16. So all the mass must divide by the molar mass. So what is the number of moles? So for this one is 0.6798. This one pun the same one. Okay, but then for the oxygen is 2.3794. Okay, So again, unless it is the final answer, you're going to take 4 decimal places. That is for the number of mole. Okay, so for the ratio, what we're going to do is actually we're going to take the number of mole and then we're going to divide by the smallest value of all the number of mole lah. Okay, so in this case, the smallest number of mole is 0.6798. So we're going to divide this, all of this individual value, divide by the same value lah, 0.6798, since it is the smallest one. So when you divide it, you will get 1 to 1. This one is 3.5. Okay, but then since this is not a whole number, we can't straight away round off the value, because it could be 4, it could be 3. Okay, so how do we multiply the value? Okay, so actually, okay, write down at the end there. Okay, if the ratio, if you got 0.33, all of the value you must multiply by 3. If the value is 0.5, if only one of the value is 0.5, then you have to multiply all the value by times 2. If the value for the ratio you got 0.25 or 0.75, you're gonna multiply all the value times 4. But since in this table itself we got 0.5, so we're gonna multiply by 2. Now the ratio would be 2, 2, and 7. Okay, so based on the Marmora table, again, Marmora stands for the mass, the mole, and the ratio. So here we know that the molecular formula will be K2Cr2O7. Okay, if you can't remember what is the symbol for the potassium, chromium, and oxygen, it's actually is available on the list of constant. Based on the list of constant, just now we only watched for the molar mass. Okay, but then you can also find out your symbol. Okay, what is the element itself lah. Okay, so we know that the empirical formula is K2Cr2O7, but then the question asks for the molecular formula. So since we already got our empirical formula, okay, so we have to find the N itself. Okay, since because this question already you got the answer, you thought that is the only solution. It's not. Actually, during the exam we do not know the answer itself, so you have to find out lah. Okay, so this one, the N is mass, is the mass of the overall. Okay, here has the molar mass here. Okay, the molar mass here is from the K2Cr2O7. Okay, again, for the molar mass, it's actually based on the empirical formula lah. So that's why, even though I know the molar mass, this one, since from the Marmora table, but then don't forget to multiply by 2 to 7. Yep, and here. Okay, so we know that the number of mole is equal to 1. So since N is equal to 1, so actually the molecular formula is equal to empirical formula. My molecular formula is K2Cr2O7. So that's the question, what the question want lah, to determine the molecular formula. But then the question asks to name X, to name the molecule itself. So K here is our potassium. Okay, but then this one we have our chromium. So potassium, usually for the chromium we call it chromate. But since our chromium we have 2, the name would be potassium dichromate. Okay, so I think that's the tricky part a bit. Actually, the tricky part of the question is for the naming. But then how to determine the answer is actually quite simple, where you have to write down, you have to determine the empirical formula, which is basically you have to remember this one lah, Marmora table. Okay, so that is the solution for question C. Now let's look for question 1D. The reaction between nitrogen dioxide and O2 with water produce nitric acid HNO3 and nitrogen monoxide NO. In a reaction between 100 gram of NO2 and 50 gram of water, 80 gram of HNO3 is produced. Question number 1. Determine the limiting reactant in the reaction. Okay, before we determine the limiting reactant, we have to find the mole. Okay, to find the mole, we have to know how many mole is actually our reactant and our product. So we have to write down the equation. So here it mentioned the reaction is between nitrogen dioxide and water. So it means that this one will be our reactant and produce nitric acid and nitrogen monoxide. This one will be our product. Okay, so let's write the equation down. So this is the equation for the reaction, but it's not balanced yet. So first what I'm going to do is actually I'm going to count how many nitrogen, hydrogen and oxygen on each of my side. I mean in the reactant side and on the product side to balance it out. On my reactant side, nitrogen is 1 because from here, hydrogen is 2 from my H2O, oxygen is 3 because 2 from here and 1 from here. Okay, but then on my product side, nitrogen is 2 because 1 is from HNO3, 1 is from my NO. Hydrogen is only 1. Oxygen is 4 because 3 from here and 1 from here. Okay, so what I'm going to do is actually I'm not going to balance the N first because from here, from this side, the nitrogen is from 2 different species. So it's easier for you to balance the hydrogen first, but hydrogen is only from 1 the species lah. So here is 2, here is 1. I'm going to balance it out. So here become 2, here become 2. Okay. So right now my nitrogen is not 2. My nitrogen will become here is 2 plus 1. So here will become 3. Okay, my oxygen is 3 times 2, 6. 6 plus 1, it will become 7. Okay. So next is actually I'm going to balance my nitrogen. Since my nitrogen on my product side is 3, so this one must be 3 lah. Okay, so 3, so this one become 3. Okay, so now my hydrogen is still 2. Okay, my oxygen is 3 times 2, 6 plus 1, so it become here 7. Okay, so now the equation is balanced where nitrogen both side is 3, hydrogen is 2, and the oxygen is 7. Okay, so this is the equation itself. Okay, next information, it mentioned that here in a reaction between 100 gram of NO2 and 50 gram of water. So I'm just going to label the information. Okay, but then they ask you to determine the limiting reactant in the reaction. Okay, so which mole or which species that we're going to use to find out the mole of our product lah. So that's why we have to find the limiting reactant since both of the information is given to you. Okay, so first what we're going to find out, the mole of NO2 and find out the mole of H2O. Okay, so how we're going to find out the number of mole? Remember, number of mole is equal to mass divided by molar mass. So the number of mole is 100. Okay, divide by, okay, the molar mass, how to find it out? We're going to find out from our list of constant. So based on the list of constant, okay, your right hand side here is actually your molar mass. Okay, so nitrogen is 14, oxygen is 16. Okay, so here the 14 is actually from nitrogen. Oxygen is 2 times O2. So the number of mole at the front here is not used when we're calculating the number of mole. This one is actually when we find out 3 mole equivalent to 1 mole of NO. Okay. This one, the stoichiometry at the front is not included in the calculation of number of mole. Okay, so from here we know that the number of mole of NO2 will be 2.1739 mole. Don't forget to write down the unit. Okay, and then the number of mole of H2O. Okay, so I'm just going to substitute all the value. Okay, so this one, okay, this is the number of mole for the H2O. This is the number of mole of NO2. Okay, so this is the available one or the provided one. Okay, this one is the one it is provided at the start of the experiment. Okay, next is actually we're going to compare the value to find out the limiting reactant. Okay, so there are two methods actually to determine the limiting reactant. Method 1 is actually you're going to compare both of the reactant with the same product. So for example, if you compare the NO2 with HNO3, make sure you compare the H2O with the HNO3 as well lah. Compare with the same product. Make sure it's the same product. Jangan NO2 compare HNO3, H2O compare dengan NO. It's not. we must compare with the same product, where we're comparing the one with the one which produce less product is our limiting reactant lah. That is my LR. Or you can compare the reactant with each other. Okay, so for example, from the question, but then for the method 2, you have to know which one is provided, which one is needed. Provided or available is the one from the question itself, and then when you compare it with each other, that is the one that is needed lah for the reaction itself. It's just that, okay, for these two methods, both is correct. Okay, for method 1 is quite a long one because you have to compare both reactant with the same product. Okay, so it seems that macam it's quite a long one. Tapi sebenarnya it's more straightforward because if method 2, you're only gonna compare it once. But then when you're using the method 2, you have to write down this statement. Okay, this one. Which statement? This one. If provided is more than needed, that is the excess. If the needed is more than provided, okay. For example, apa yang diberi lebih banyak daripada apa yang kita perlu. Okay, so maksudnya kita excess lah. Okay. Tapi apa yang kita perlukan lebih banyak daripada apa yang being provided. That is our limiting reactant. Okay, so for method 2, it seems much more simple because actually kamu kena compare sekali je. But then you have to write down this statement. Okay. So takut this part is where you got the wrong answer. Actually, when you're comparing, you got the right one. So that's why it will be easier for you and much more simple, okay, and straightforward to do the method 1. So that is the one that I'm going to do, where I'm going to compare. So the method 1 is the one that I'm going to do for question D1. Okay. So I'm going to compare the NO2 and the H2O with my HNO3. So again, we're going to do it one by one. Remember, compare both reactants with the same product. 3NO2, I'm going to compare with HNO3. This is where the stoichiometry is very important lah. Okay, again, the stoichiometry is not included in the molar mass, but it's actually when the comparison. Okay, so for this one, we're going to find out through cross multiplication. So we know that when we're using mole of NO2, we're going to produce 1.4493 mole of HNO3. Okay, this is when we're using NO2 as our reactant. How about if we use H2O as our reactant? So I'm just going to write it down again. Make sure when you're comparing, the stoichiometry is the correct one lah. H2O is this one, okay, not this one. Okay, so we know that my X is actually for when we use H2O, so we know that the mole produced will be 5.5556 mole of HNO3. Okay, again, unless it is the final answer, we're just going to take 4 decimal places. Okay, once we have compared it, okay, so we have the same product, but then we have 2 different value. Okay, and then we compare lah. Which one is, which of the reactor will produce less amount of product? That will be our limiting reactant. So in this case, we're going to compare 1.4493 and we're going to compare 5.556. Hence, we know that my NO2 is the limiting reactant. Okay, so that is only it lah. So that is to determine the limiting reactant, question number 1. Next is question number 2 is to determine the percentage yield of the reaction. Okay, so for question number 2, again, I'm going to write down the information from question number 1. So we know the balance equation, we know the number of mole, and then we know the limiting reactant. Okay, and then from the information, okay, there's one more information I haven't written down, which here it mentioned that 80 gram of HNO3 is produced. So here is 80 gram. Okay, so what is the formula for the percentage yield of the reaction? Okay, formula is actual yield divided by theoretical yield times 100. Okay, so actual yield is actually given in the question lah. Usually, that's the one that is given. Kalau theoretical is the one that you have to find through your calculation. Okay, so it's different. Okay, so based on the information given, so again, actual yield is the one that given in the question. So in the question give you 80 gram of HNO3. HNO3 ni is not your reactant kan, it's actually your product. Okay, and the yield itself is actually specifically untuk product only. Yield tu it means that the product itself lah. Okay, usually the yield is something that is tangible, something that you can see. It's either in gram or in ml. So if the question give you actual yield in gram, so it means that this one you have to find in gram lah. If the actual yield is given in ml, this one you have to find in ml. Okay, so since this question give you the theoretical yield is 80 grams, so you have to find, since the question give you the actual yield is 80 gram, so you have to find the theoretical yield in gram as well. Okay, so actual yield, we know that it's 80 gram. But then how to find the theoretical yield? What does it mean by find through calculation? Okay, so to find through calculation is actually when you compare it. Okay, so when you're comparing, you're going to use the limiting reactant. Okay, so again, we're going to find out the number of mole of HNO3. Okay, so I'm just going to use, based upon the equation itself, we know that 3 mole of NO2 is equivalent to 2 mole of HNO3. Okay, so from here, the HNO3 mole is our unknown X. So when we do cross multiplication, so we know that the value of X will be 1.4493 mole. Okay, don't forget about the unit. Okay, so now I know that the HNO3 its mole is 1.4493. But then again, okay, yield, actually since the question already given the actual yield is in 80 gram, okay, theoretical yield must be in gram. But right now, what we have is actually in mole. So how to change from the mole to the gram? So based on the formula, number of mole is equal to mass divided by molar mass. Okay, so the number of mole is 1.4493. Okay, the molar mass is HNO3, hydrogen is 1, nitrogen is 14, and oxygen is actually 16. Okay, our mass of our HNO3 is 91.3059 gram. Okay, so this is actually our theoretical yield. Okay, this is in theory when we calculated through stoichiometry. Okay, so the question asks for the percentage yield. Okay, so I'm just gonna write down my percentage yield. Okay, so since this is the formula, actual again based on the question itself. Okay, so the question give 80 gram. The theoretical yield is the one that we have calculated, which is 91.3059. Okay, so the answer would be 87.62%. Okay, so that is actually your percentage yield. Okay, remember for the percentage yield, actual usually is given in the question itself. Theoretical is the one that you must find yourself through the calculation, where usually you're going to find out the limiting reactant, then you're going to find out the mass or the volume of your product. Okay, since the question give you HNO3, so that is the actual yield. Theoretical yield must be the HNO3 lah. The question give you for actually NO, so you have to find out the theoretical yield for NO. Okay, so that's it. The last question for PSPM 2020-21 for chapter 1 questions.